Okay, this is chapter 12, lesson 1, and chapter 12 of year 13 is all about 3D vectors. You will need the stuff that you should know from year 1. So if you're still not that sure on vectors from year 1, don't just let it be. Go back and have a look at it and try to figure out some of the bits and pieces that are involved in that, because you'll need it for the later parts of this chapter. That being said, this first lesson is dead easy. It's all about coordinates and magnitudes in 3D. So we've got find the distance from the origin to the point 2, 3, 4. Now what you'll notice is this is obviously 3 dimensions, because we've got an x part of our coordinate, we've got a y part, and we've got a z part. Okay, there's an x, y, and a z, and those are our 3 dimensions: x, y, and z. And it can be quite tough to visualize this. I know that when I was doing my A level, I found it quite confusing to try to visualize roughly where that would be. And one thing that I used to try to imagine was maybe like a cuboid sitting on the axes. Okay, and so I could kind of imagine that across the space diagonal of the cuboid, you should know the terminology space diagonal from GCSE, across the space diagonal of the cuboid would take me from the origin to this new point. Okay, so we've got the point 2, 3, 4. Let's take a look at it. So in GeoGebra, I've got this point here, which is A, which is 2, 3, and 4. So it goes across 2, up 3. But where does the 4 come in? Well, the 4 is this extra dimension, and A floats up there, and it can be really difficult to think of where that is. Okay, you've got 2 and then 3, and then A is almost pulling it closer to the 4. Sorry, is almost pulling A closer towards you than the plane would be between the x and the y axes. Okay, so it's up there, so it's quite tricky to think of. So finding the distance from the origin to that point, we're finding the distance from 0, 0, 0 to 2, 3, and 4. Okay, sometimes that's called the magnitude, but in this case we're going to call it the distance. Now, the way that can be worked out is you can use Pythagoras on it, and you can say, well, if I've got x2 subtract x1 squared plus y2 subtract y1 squared plus z2 subtract z1 squared, that will give me the magnitude, okay, between the 2 coordinates. Now in this case it's dead easy, because we're going to be doing 2 take away 0, 3 take away 0, and 4 take away 0. So distances from origins to points are dead simple. You're going to have the square root of, all of, will have 2 squared plus 3 squared plus 4 squared. Okay, now 2 squared plus 3 squared plus 4 squared, 16, and 4 makes 29, so we'll get the square root of 29. Okay, and that will be the distance from the origin to that point. Nice and easy, it's just Pythagoras. Alright, moving on though, same formula this time, but we've got 2 different coordinates. Okay, we haven't got the origin anymore, so x2 subtract x1 all squared plus y2 subtract y1 all squared plus z2 subtract z1 all squared, and then rooted will give us that distance, or the magnitude it's sometimes called. Essentially what you're doing is you're finding the distance between these, and if all you think of is the difference between 1 and -3, which is 4, it's going to be squared anyway. So if you should get -4, -3 take away 1 is -4, it's going to be squared anyway, so it's not the end of the world if you just treat it as a 4. Okay, so we've got -3 take away 1, which is going to be -4 all squared, plus 4 take away 2, which is going to be 2 squared, plus 0 take away 3, which is going to be -3 squared. Okay, that is going to be 16 plus 4 plus 9 in the root, and that will be root of 29. Okay, which is weirdly enough the exact same as the previous question, but it's not always going to be, of course. Okay, hopefully that's okay so far. Now the distance between the points here, where we've got 1, 2, 3 and 4, 3, z, is root 26. Find the possible values of z. So first we've got 4 take away 1 all squared is our change in x squared, and then we've got plus 3 take away 2. If you mix the order up around with those, it doesn't really matter too much. Plus z take away 3, all squared. And when we root that, we're going to get the exact same thing as root of 26. Okay, I'll cancel off the roots, and what I'm going to get is going to be 3 take away 1, which is 4 take away 1, which is 3 squared is 9, plus 3 take away 2, which is 1 squared is 1, plus z subtract 3 all squared is equal to 26. It might be your inclination to try to expand that, but actually you'll see in just a second why it's probably not the best idea. Okay, I'm going to subtract 10 from each side, I'll get 16, and now I can just isolate the z. When I square root the 16, make sure that you include the positive and the negative, so you'll get z minus 3 is going to equal plus or minus root 16, which is 4. Okay, when you square root 16, you'll get plus or minus 4, and then we'll move over the negative 3, so we'll get z equals 3 plus or minus 4. So z has two potential values, z equals 7 or z equals negative 1. Okay, 3 plus 4 is 7, 3 take away 4 is negative 1. Hopefully that's all okay. It's not too difficult really. This is a nice start to a chapter, and to be fair, the vectors chapter isn't too difficult. So your tasks are on the Edexcel Year 2 book, page 339, exercise 12a. I want you to just do all of the questions, 1, 2, 3, 4 and 5. There's no extension in this because it's just really, really simple. It shouldn't take you more than about 20 minutes or so. Okay, make sure you've marked it, make sure that you've uploaded it to Google Classroom and you ask any questions that you need to. Good luck.